Hello friends, today's subject of data structure and algorithm, unit number 3. Today's lecture will be covered of BFS and DFS, application of BFS and DFS algorithm, tree versus graph, spanning tree of graph, minimum spanning tree application, greedy strategies, minimum spanning tree, Prim's or Kruskal algorithm. First, compare of BFS and DFS. BFF is find the shortest path to the destination, and DFS is goes to the bottom of substrate and backtrack. Second point, the full form of BFS is breadth first search, and full form of DFS is depth first search. Third point, it uses a queue to keep track of the next location to visit. It uses stack keep track of the next location to visit. BFS travels according to the tree level, and DFS is travels according to the depth. BFS it is implemented using FIFO, means first in first out, and DFS is implemented using FIFO list, means last in first out. BFS is require more memory as compared to DFS, and DFS are less memory compared as to BFS. Next, application of BFS algorithm. BFS can be used to find the neighboring location for a given source location. In a peer-to-peer network, BFS can be used as a travels method to find all neighboring nodes. Most torrent clients such as BitTorrent, uTorrent employ this process to the seeds and peer in the network. BFS used to determine the shortest path and minimum spanning tree. BFS is used to chain technique to duplicate the garbage collection. It can be used to for full course method to compute the maximum flow in a network flow. To build the index by search for GPS navigation. Third, find path algorithm, cycle detection in an undirected graph in minimum spanning tree. Application of DFS algorithm for the finding the path. Second, to test if the graph are by path. Third, for the finding the strongly connected component of a graph. And next one, for detecting cycle in a graph. Next, difference between tree and graph. First is graph and second is tree. Graph is a non-linear data structure and tree is a linear data structure. Second, graph, it is a collection of vertices, nodes and edges. Tree is a collection of nodes and edges. Graph, each node can have number of edges. Tree, general tree consists node having any number of child node, but in case of binary, every node can live at the most 2 child node. Graph, there is no unique node called root in a graph. There is unique node called root is tree. A graph is a cycle can be formed, and tree is there will be no any cycle. Application of graph for finding shortest path in networking. And next, application of tree for game tree, decision tree. Next topic will be spanning tree of graph. A spanning tree is a subset of graph G which has all the vertices covered within a minimum possible number of edges. Hence, a spanning tree does not have cycle and it cannot be disconnected. Application of spanning tree. First application is computer network routing protocol. Second, cluster analysis. Third, civil network planning. Minimum application, minimum spanning tree application to find path in map. Second, to design network like telecommunication network, water supply network, and electrical grids. Greedy strategy. In an algorithm designed to achieve optimum solution for a given problem. In algorithm approach, decisions are made from the given solution domain. As begin greedy, the closed solution that means to provide an optimum solution to choose. Example of greedy strategies. First, traveling salesman problem. Second, Prim's minimum spanning tree. Third, Kruskal minimum spanning tree algorithm. Dijkstra minimal spanning tree algorithm. Snapshot problem. Job scheduling problem. First, minimum spanning tree, Prince or Kruskal algorithm. The cost of the spanning tree is the sum of weight of the all edges in the tree. There can be many spanning tree. Minimum spanning tree is the spanning tree where the cost is minimum among the all the spanning tree. There can also many minimum spanning tree. First, Prim's algorithm. Prim's algorithm are used to greedy approach to find the minimum spanning tree. In Prim's algorithm, we grow the spanning tree from a starting position. Unlike an edges in Kruskal, we add a two vertex growing spanning tree in Prim's. Next, algorithm for Prim's algorithm. First, initialize the minimum spanning tree with a vertex to choose at random. Second, find all the edges that connect the tree to new vertices, find the minimum and add it to the tree. Third, keep the repeating step number 2 until we get the minimum spanning tree. Prince algorithm complexity. The complexity of Prince algorithm is V log E log V. Example of Prince algorithm. There are number of vertices V1, V2, V3, V4, V5, V6 and V7. The select the minimum edge of V1 and V4 are the selected edges to low cost. First of all, V1 and V4 are selected. This means the cost will be R1. Then next will be selected edges V1 to V2 is minimum cost of 2. The path length will be 3. Next, the V4 to V3 select the edges. The minimum cost of in these edges is path length will be 5. Next, the V4 to V7, the minimum cost of edges, the path length will be 9. Next, the V7 to V6 is minimum cost of edges, the total length of path is 10. And next, final last node will be remaining V5, V7 to V5, minimum cost of 6. The path length will be 16. Those minimum spanning tree with the path length is 16 is of them. Prince algorithm application. Laying cable of electrical wiring in network design to make protocol in a network cycle. Kruskal algorithm. Kruskal algorithm is a minimum spanning tree algorithm that take a graph input and find the subtree of the edges of that graph, which from the tree that include every vertex has the minimum sum weights among all the trees can be formed from the graph. Kruskal algorithm complexity is the time complexity of Kruskal algorithm O E log E. Algorithm of Kruskal algorithm. Step 1 is sort all the edges from low weight to high. Second, to take edges with the lowest weight and add it to the minimum spanning tree. If adding the edges and create cycle and then reject these edges. And third, keep adding edges until we reach the all vertices. Example of Kruskal algorithm. There at select the edges of G to F is the minimum cost. Then next will be selected D and E is the minimum cost. Next select the edges E and H is the minimum cost is 13. Then next select the edges B and C with the weight of 20. And next select an edges A and B's weight is 30. And next select the edges and H and G with the weight of 70. And last one they select the edges of C and D with the weight of 29. With cycle will be completed the total weight of 134. Kruskal algorithm application in order to lay out electrical wiring, and second is in computer network LAN connection. Thank you friends for watching this video.